So today I want to go over more information about double replacement reactions. So last class I showed you guys how to figure out the products of these. And today what I would like to do is to go over how you can figure out if these reactions will occur or not. So we will not be using the activity series to help us to figure out if these reactions will occur. We instead will use a solubility table that is on the same reference sheet that you guys were using last class, which had the activity series on it. So when you're writing these types of reactions, you have to assume that everything you see in your reaction is in water. You're also going to have to, just like we did last class, figure out the charges of your cations and anions of your reactants. You have to remember then that the metals or nonmetals are switching places and then predict the products using the crisscross method. The new thing is that you're going to use the solubility rules, and we'll go over how to use those to determine if the reaction can occur. You will need to write your symbols like AQ for aqueous or S for solid. And remember, the aqueous means it's dissolved in water. So for the reaction to occur, all the reactants must be dissolved in water. They must be aqueous. So when I showed you guys that video of the reaction between lead 2 nitrate and potassium iodide, you could clearly see at the beginning that the two reactants were dissolved in water. But typically you'll either have to be told that, since you most likely will not be able to see the reaction occur, or you will have to figure it out using your solubility table. The products must include at least one of the following. They must include a precipitate, that means a solid. They must include a gas or a covalent compound. Most commonly, this will be water. They can include two of these things, but they have to include at least one. If these requirements are not met, either that both the reactants are not dissolved in water or that you do not have one of these as products, then you need to write that the reaction will not occur. Okay, so when you're doing this, you're going to first write out your balanced molecular equation. If the reaction doesn't occur, I want you to state why it does not occur. You're going to then write out any dissolved ionic compounds as dissociated free ions. And I'm going to show you an example so you can see how what I mean by this. You're going to cross out anything that remains unchanged from the left side to the right side of the equation. These are going to be called spectator ions. And then you're going to write the net ionic equations with anything that remains. Okay, so these are the steps that we'll be doing. So make sure you have written these down. And then as we work through examples, you're going to see what each of these steps kind of means. Okay, so I want to look at the reaction that we did last class in the demonstrations so that you guys can see how we could figure out from this, like which of these compounds in the product would be our solid in this case. Okay, so I'm gonna bring up your solubility table. So your solubility table is the reference sheet you were using last class for the single replacement reactions. So let me bring this up. Okay, by doing this, I hope to begin to show you how you can use the solubility table to figure out, in this case, which of our products is a solid and which one is dissolved in water. Okay, so our two products, if you remember, are potassium nitrate and lead 2 iodide. So when you're doing this, I want you to examine, you will have, in this case, a cation and an anion, and a cation and anion. So our cation in the first place is K+, our anion is NO3-, our cation in the second place is Pb2+, and our anion is I-. So we're going to start with the solubility rules, and I'm going to examine first the potassium nitrate, and I'm going to look for a solubility rule that applies to either potassium, in this case K+, or nitrate. Once I find a solubility rule that applies to one of these, I will stop. So if I look at the first solubility rule, you will see I see right away that there's a rule that applies to nitrate. This says that all nitrate salts are soluble. I then want to look for any exceptions. So I want to go over to this column with important exceptions. The only exceptions I can see here have to do with silver nitrate, nitrite, and potassium perchlorate. So exceptions in this case say it's slightly soluble. Whenever you see the word slightly soluble, that means even if you have if you were to look at it with your eyes, it would appear insoluble, but if you were to get a microscope, you might see a few ions in solution, but visibly it would appear insoluble. So this tells me I don't have an exception. So this tells me that this compound right here is aqueous because it says all these are soluble and I don't have an exception. Now let's look at lead 2 iodide. Okay, the first rule does not apply to lead 2 iodide, does not apply to lead or iodide. The second rule does not apply to either one of those either. The third rule, though, does apply. So this says halogens. Iodine, remember, is a halogen. It says all of these are soluble, but I want to look at the exceptions. It says exceptions are lead. This means since it's an exception, it's going to be the opposite. It's not going to be soluble. It's going to be insoluble. So that means that this one is a solid. So it's a precipitate. So let's go back to our slide. So this means that this one here is a precipitate. So I'm going to write a solid. And this one's aqueous. So if it's slightly soluble, or insoluble, it is a solid, which means precipitate. Okay, so we're going to go, what I want you to do now is I want you to practice using the solubility rules and to practice using the solubility table, just like we just did. So I'm going to bring this up. I want you to try these 4 compounds here. So pause the screencast, try those 4 compounds, and then we're going to go over the answer. Okay, so let's go over these 4 answers so you guys can check them. So I'm going to bring up your solubility table. So let's go over these 4. So I've written them down here next to your solubility rules, and we're going to look at each one of these so you guys can check your answers. For the first one, remember, think of each of these as the 2 different ions. So we have Na plus and then SO4 2-. So we want to start with the first solubility rule and go down until we run into a solubility rule that applies to one of these ions. So if we look at the first solubility rule, this does not apply. The second one does apply. So it says essentially all alkali metal salts are soluble. We don't have an exception. So this means this is AQ. So don't keep looking until you find a rule for sulfate. If you do, you're going to get your answers wrong. So stop as soon as you find a rule that applies to one of the ions in your compound. Don't keep going. Okay, so let's go over the next compound. So with magnesium carbonate, we have 2 ions. We have magnesium 2 plus and carbonate 2-. So we look for magnesium. What you'll see is if you go through this list, you won't see a rule that applies to magnesium. The first rule that we do see that applies in our situation is this rule with carbonates. It says that most carbonates are slightly soluble. We do not have one of the exceptions for any of these. So this means that this would be a solid. So we would write S for since it's slightly soluble. For the next one, we have lead, and we have Pb2 plus and Cl minus. Okay, the first rule we see that applies is rule number 3. It says most halogens are soluble, but we have an exception. We have Pb2 plus. So again, this would be a solid. We look at the next one, magnesium chloride. This same rule applies for magnesium chloride because we have Mg2 plus and Cl minus. So we see that most halogens are soluble with magnesium chloride. We do not have an exception, so this would be aqueous. Okay, so for that, you should have gotten sodium sulfate was aqueous. The next two are solids. Magnesium chloride is aqueous. Okay, so now we're going to do how to go through a net ionic equation. So let's bring that up. This sheet is under classwork. First thing you want to do when you're doing these is actually write out your balanced equation and then figure out your states of matter and everything. So let's do the first one. Okay, so we have to write out our balanced equations. So we have lead to nitrate, PbNO3 2 plus KCl. Okay, for this sheet, I want you to assume that all reactants are aqueous. Okay, so for this one, we can assume these are both aqueous. Okay, so we're going to do the crisscross method. Lead will keep its +2 charge and it will end up with chlorine. And then potassium will end up with nitrate. Okay, so we just saw from this that lead to chloride is a solid, so it's going to be precipitate. Potassium nitrate, if we look at it, potassium is an alcohol. Actually, the first rule applies. We have a nitrate salt. We don't have an exception, so this means it's soluble, so it's aqueous. Now we want to balance our equation. So we want to put a 2 here and then a 2 here to balance our equation. So our equation is balanced. For the complete ionic equation, I want you to take anything that says AQ and split it apart into its ions. So here we have Pb 2 plus. Each ion will be AQ. This 2 becomes a coefficient for the nitrate. This coefficient will go with each of the ions, so we have K plus. Anything that's solid will stay together, so we will keep PbCl2 together. And then again, this is aqueous, so we split it apart, and the coefficient goes to each of the ions. Okay, for the net ionic equation, we're going to look for anything that is on both sides of our equation and cross it out. So we see potassium's on both sides, so we're going to cross that out. We see that nitrate is on both sides, so we're going to cross that out. We're only going to write what is left after we've crossed those things out in our net ionic equation. And you notice here that my precipitate stays together still. Now you will also notice my complete ionic and net ionic equations are balanced, just like my molecular equation is balanced. If they are not, I might have made a mistake. Now anything I did cross out is a spectator. It's kind of like when you see a fight in the cafeteria, you have some people that are actually fighting and some people that are watching. Those are your spectators. They're not involved in the fight. So here, our spectators are the potassium ion and the nitrate ion because they're not involved in the reaction. So we have here NO3 minus. So I do include the charge because these are ions. And I'm also indicating that they are dissolved in water, but I do not bring down the 2 because that would simplify and those would go away. So that is our net ionic equation and our spectator ions. I want to do one more just to show you guys a slightly different scenario. So let's do this one. For this one, we have HCl. And remember, we're assuming all our reactants are aqueous, plus barium hydroxide. So here, you actually form BaCl2, and you form HOH, which is water. This is H2O. Now, water will be liquid. So it's not going to be, we do not use our reference sheet to figure out water. Water is just it's a covalent compound, it's liquid. Now let's look for barium chloride. So barium chloride does have the third rule apply. It says all halogens are soluble. We do not have an exception. So if we go to our sheet, this means that this is AQ. Okay, so now we're going to balance it. We put a 2 here, and we put a 2 here, and now it's balanced. Now this is a situation where this requirement of having a covalent compound, for example water, would allow this reaction to proceed. So this reaction will occur. So again, we're going to split up anything that is aqueous. We have 3 things to split up. And then anything that is solid, or in this case liquid or gas, will stay together. So we have 2H plus AQ plus 2Cl minus AQ plus Ba2 plus AQ plus 2OH minus goes to BaCl, Ba2 plus AQ plus 2Cl minus AQ plus 2H2O liquid. Okay, we're going to cross out anything that appears on both sides so we can get rid of the chlorine ions, to get rid of the barium ion. And we're left, and I'm going to simplify this to H plus, since all the coefficients are 2. And then what I crossed out becomes my spectator ions. So we have Cl minus, AQ, and Ba2 plus, AQ. Okay, so that's the process of how to figure out a net ionic equation. So I want you to try these for homework. There's a front and a back to this sheet. If you're having trouble with this, please make sure you sign up for a tutorial.